your exam. Okay. Yesterday you asked, na? So which questions you have to doubt? I will explain you. The screen is visible right now.
Yes, sir.
Yeah. So I think everyone know about the first answer, dual nature of the matter waves. Okay. So proposed by who is that? De Broglie.
Exactly.
Yeah, that is the right answer. And next one, second one is the wavelength of matter wave of an electron moving under the influence of potential V is proportional to. So what is the answer?
C, sir.
C na. Uh, D answer. So what is the answer? Lambda is equal to, what is the de Broglie wavelength formula?
12.26 by under root of V, sir.
Electron moving under the influence of potential V. Yeah. So answer is the C. Okay. So 1 by root V. So proportional to 1 by root V. 12.26 by root V. Okay. So that is the answer. Answer is C here. Next. So what did the Compton discover after bombarding the electron with high energy photons? What happened here? That Compton bombarding the electrons with high energy photons. What happened here? Photons
Electron
momentum
and positron comes.
electron. So option C you are saying. So which is the option? So here positron is not coming into the matter. Okay. So that means Compton effect. What is the Compton effect? High energy photon is collide with the so electron scatter. What happens? Collision with the electron. Okay, photon with short wavelength can be ejected. So this is wrong because photon wavelength will be increases. Okay, option B is wrong. So option A, photon's momentum depends on the wavelength. So photon momentum is does not depends on the wavelength. Okay, and electron positron come in pairs. So electron can be split into the smaller particles. So electron does not split into the smaller particles. So option 1 is correct because so electron momentum equal to P is equal to hc by lambda na. What is the formula? Electron momentum formula hc by lambda. So that's why option A is correct. Photon's momentum depends on its wavelength. So because formula is equal to so P is equal to hc by lambda. Okay, so remaining all
Sir,
are wrong.
positron.
So that is
The
positron not
positron
uh, yes.
means it is a proton with a less mass, no, sir. So obviously it will move with a higher wavelength, no, sir.
Yes, higher wavelength. But here given short wavelength. Okay,
Sir,
short
then
wavelength
C
is
will
wrong.
also be answered, no,
So
sir.
C is
Because
wrong. So
positron is
positron is so what is the definition of positron? So what is the meaning of positron?
a proton with lesser mass, no,
No, that is no, that is not positron. So positron means it is similar properties to the electron, but it will be opposite charge of the electron. Opposite charge of the electron. That is the positron. So that positron comes in nucleus matter. So it will not comes into the so here. Okay. So that positron term will come into the nucleus matter. Okay, so whenever we are dealing with the nucleus, so that will positron will come. Okay, so that's why so that is wrong. Option C is wrong. Only option A is the correct answer because so photon's momentum depends on the wavelength. Okay, so that means here P is equal to hc by lambda photon momentum. So that option A is the correct here. Any doubt?
no, sir.
Yeah. Now coming to the so fourth one, division in Germa experiment. Okay, so when 50 volts was applied to the electrons, the what is that? Pronounced scattering direction was found to be. So what is the, if you apply the 54 volts, so what is the direction? Already
50
graph we
degrees.
know that. Yes, 50 degrees. Answer is option B. Okay. And here delta E and delta T are the uncertainties in the measurement of energy and the time of a system according to Heisenberg uncertainty principle. What is the answer?
A, sir.
Yes, option A is the answer. Okay. Now, if 100 volts is potential with which the electron is associated, okay, then the wavelength associated with the electron. Here, voltage is given. So, that means what is that we have to find? Wavelength we have to find. Directly we know the formula. Lambda is equal 12.26 by root V. Okay. From that we can get the answer. So root 100 means so it will be 10. Okay. So 12.26 means we are taking in nanometers. So 12.26
Sir,
by nanometers means 1.226.
excuse me,
Okay.
sir.
Yes.
Sir, the formula is 12.26 by under root V Armstrong, sir.
Yes. Angstroms, huh? Okay.
Yes,
Yeah.
sir.
12.26 by angstroms. Mm. Okay. If it will be angstroms means it will be option is C. Okay. So that formula will be in angstroms means option is here. C is the right answer. Okay. Now we are going to the seventh one. If the particle moving in a dash potential, then the solution of wave equation are described as stationary state. Okay, if the particle is moving in a that means what we have to find out where it will be moving. We have to
Time independent,
specify.
sir.
Yeah, so time independent. Option A is the correct answer. So next, the square of the magnitude. Yes, the square of the magnitude of wave function is called. Okay, the square of the
Probability,
magnitude.
sir.
uh, so probability, current density not, zero density not, volume density not. Only answer is so probability density. So option B is the answer. So next one, Schrodinger equation described the. Schrodinger equation described the. So what it will describe? So option A, produce for splitting an atom. So option B, complement of the wave function. So option C, behavior of matter waves. So option D, none. So what is the answer?
Complement of wave
No.
function.
Schrodinger equation describes the behavior of matter waves here. Option C is the answer. Okay, so that means for Schrodinger equation, suppose Schrodinger equation, so will be differential equation of wave function. Okay, what is the wave function? So wave function describes the matter waves. So that means solution of for finding the position and momentum velocity. So for all that, so we'll use Schrodinger equation. So that's why it explains the behavior of matter waves. Okay. So next, 10th one, velocity of matter wave is always. So already I explained you. So matter wave velocity is greater
Greater
than the,
than, sir.
yes, velocity of light. So that is the option A. Next coming to the second unit, intrinsic semiconductors are those. So what is the intrinsic semiconductors? What is the property of intrinsic semiconductor? Option D.
Made
So
of
which are,
purest form.
yes, option D is the answer, made of semiconductor material in purest form. Next, intrinsic semiconductor at room temperature will have that's available for conduction. Okay, so in intrinsic semiconductor at room temperature, so what are the charge carriers?
Both electrons and holes, sir.
Yes, both electrons and holes. This is the so option C. So someone told that there is at room temperature there is no electrons and holes, so none of the above antaru. So but that is wrong, because so at very low temperatures, so there is no charge carriers. But room temperature, that is the sufficient energy for semiconductors, to conduct it. Okay, that's why. So both electrons and holes will be present in case of intrinsic semiconductor at room temperature. But so those carriers value will be less. Number of charge carriers will be less. Okay, number of holes and electrons will be less at room temperature. If you increase the temperature, means those charge carriers also increases. Okay. Now, so yeah, next one, 13th one. A pure semiconductor behave like an insulator at 0 degree Kelvin, because what is the reason? So if you will take intrinsic
Free
semiconductor,
electron.
free electrons
Yes, sir.
not available. So you are saying option B.
Yes, sir.
Okay, that is correct only. And what is option A? There is no recombination of electron. So either electron holes are not present at all. That's why the option A is wrong. So drift velocity of free electron. So there is no free electrons. So that's why. So we cannot consider the drift velocity here. So option D is energy proposed by electrons that have low temperature is almost zero. So there is no free electrons at all. That's why. So we will not consider this energy of the electron also. So option B is the right answer. So free electrons are not available for current conduction. Okay. So that absolute temperature means it's 0 Kelvin. Okay, 0 Kelvin, there is no free electrons. At room temperature, so free electrons will be available. Okay. Okay. Next, 14th one. The energy gap is much more in silicon than in germanium, because so energy gap is much more in silicon compared to the germanium. So what is the reason? Do you know that? So option A, it
Its
is
valency electrons
its valency electrons are
tightly bond to their parent nucleus.
yes, that is the correct answer. So because so if the valence electrons tightly bond, then only so for removing those electrons we need high energy. We need high energy. Okay, that's why here silicon have some more energy gap, energy band gap than germanium. Okay, next, as the temperature of semiconductor increases its so temperature of semiconductor.
Conductivity
Yes. So if
increases.
you increase the temperature, what happen? Free charge carriers will be increases. Free charge carriers will be increases. That's why conductivity increases. Okay. In case of metals, what happen? Anyone? If you increase the temperature, so whether conductivity is increases or decreases. In case of metals, huh?
Increases unto a certain stage and decreases.
No, no. In case of metals, it will be decreases. Okay, with increasing the temperature. In case of metals, so that means we are considering up to room temperature only, not what is that, 0 Kelvins. Okay, so in case of metals, if you increase the temperature, conductivity will be decreases. So if you go to the lower temperature also, in case of metals, conductivity will be increases. And that means if you reducing the temperature, also, in case of metals, conductivity will be increases for reducing the temperature. So up to particular temperature, what happen? Suppose if you will take mercury will be there. So if you reduce the temperature of mercury up to 4 Kelvin, there is no resistivity. That means resistivity will become zero. So conductivity will become infinite. Okay. So that means below 4 Kelvin, mercury will act as a superconductor. Okay. So that means in case of metals, while increasing the temperature, what happen? Conductivity will be decreases. If you suppose decrease the temperature, conductivity will be increases. Decrease the temperature, conductivity will be increases. At a particular temperature, conductivity will become infinite. Okay, so those materials we will call it as superconducting materials. Superconducting materials. That is about the in case of metals. Okay, now coming to the 16th one. Consider the energy level diagram of intrinsic semiconductor. The Fermi level lies in the. Okay, so here energy level diagram of intrinsic semiconductor. Okay, so where it will be lies?
In the forbidden band, sir.
Yes, so it will be in the forbidden band. Okay, so that means forbidden band means so gap between the valency band and conduction band. Okay, so that is the answer will be option B. So option 17. Dash is used to describe the static VI characteristics of a junction diode. So what is the equation? Which equation we are using here? IV for explaining the IV characteristics. So is it Boltzmann
Boltzmann
diode
diode.
equation? Huh?
Yes, sir.
Is that correct? So
Yes, sir.
yeah.
Boltzmann
Next one
diode
is
equation.
the Richardson. What is the Dushman equation? So next one Einstein photoelectric equation. Next one Schrodinger timing. So last two answers are not correct. So we have to check. So what is the in these two? So once I will check the answer. So option 17A. Okay, yeah, you are correct. So Boltzmann diode equation. Okay, so so for finding the IV characteristics, we will use the here Boltzmann diode equation. So next one, which of the following material can be used to make light emitting diode? Okay, so here which material we are using? So silicon, germanium,
Gallium
yes,
arsenate, sir.
gallium arsenide, because so in case of LEDs, so we are using compound semiconductors. So but silicon and germanium are the not compound semiconductor. Okay, and here phosphorescent materials are we are not using. Okay, so what is the option is so gallium arsenide. This is the compound semiconducting material. Okay, next one in the Hall effect. The Hall effect, the electric field is in x direction and uh, velocity is in y direction. So what is the direction of magnetic field? So velocity is nothing but here, so motion of the electron. That means current direction. Current direction. So here electric field direction is x direction. So current direction is y direction. So what is the direction of magnetic field? What is the direction?
Z.
So yeah, z direction, because so so electric field, here current direction, magnetic field. So these three are what is that, perpendicular with each other, perpendicular with each other. So another perpendicular direction is z direction only. Okay, now Zener diodes are also known as, so what is the answer? So option A, voltage regulator.
Sir.
Voltage regulators. So option B is not correct. So breakdown diode is not correct. So none of the mention also not correct. So only
Sir.
option is the yes.
Sir, actually we tell that Zener diodes are also as breakdown diodes also, no, sir. Because
No,
breakdown voltage it's there, no, sir. Like for
yeah,
Zener voltage we
breakdown
then say
voltage.
breakdown voltage.
Okay,
So
yeah,
few
I
of
will
them say
explain.
breakdown diode is
Yeah,
also known as Zener diode.
no, so that is not correct, because so in normal diode, normal PN junction diode, so breakdowns will be occur. So I said that so that the breakdown will be occur in PN, normal PN junction diode. But if you will take, so that means after breakdown diode voltage, what happened? The diode will not work. After breakdown voltage, the diode will not work, because so that bonds will be breaks and the diode will be heated and the diode will be damaged in case of normal PN junction diode. But so if you will take Zener diodes, so where it will be breakdown occur, so that at that breakdown voltage only we are operating. So because here breakdown does not occur, just tunneling will be occur. Okay, so tunneling of the electrons and electrons from p region to n region, so tunneling will be takes place here at the breakdown voltage. So here breakdown does not takes place, only tunneling will be takes place. So I explained you. So there are two types of breakdowns will be there: avalanche breakdown and Zener breakdown. Okay, at the Zener breakdown, so what happened? So covalent bonds does not breaks, just they will tunnel from one region to another region. Okay, so that will be occur at the Zener diode, at the junction of Zener diode. That's why we will call it as this is the voltage regulator, not breakdown diode. Okay, answer is so option A. So when forward biased, LED emits light because of, what is the answer? So 21. When forward biased,
Recombination of carriers.
yeah. So recombination of carriers is one option. So and second option is light generated in breaking the covalent bonds. Okay, that is not coming here. Okay, and light produced by collisions, that is the not answer. So and all of the above reasons. So these three are wrong. Below three. So because so here light is generated in case of photodiodes, not LEDs. Okay, generated in breaking of coal. So if break the covalent bonds, energy is required, but here light is not generated while breaking the covalent bonds. So light is required, it absorbs the light, it's not generates the light. So that's why option B is wrong. Okay, light produced by the coal. So due to collisions light does not produce. Okay, due to collision what happened means they comes to the ground state and recombination will be takes place. So while recombination process, what happened here, uh, what is that, LED emits the lights. So that's why option A is the correct answer. Option A is the correct answer. Okay, now LED works on the principle of, okay, so what is the principle here?
Electroluminescence.
Yes, electroluminescence is the right answer. Electroluminescence is the right answer. Okay, remaining all are the wrong. Okay, now what is the operating voltage of LED? Operating voltage of LED.
D, sir. 1.7 to
Yes,
3.3.
yes. Option D is the right answer. So 1.7 to 3.3 volts. Okay, this is the operating voltage of LED. Okay, and next one, photodiode is used in reverse bias because, what is the reason for using,
Reverse
why we will use?
saturation current is small
Uh,
compared to
yeah,
photocurrent.
yes, that is the correct answer. Okay, first one is only the one side illuminated. Okay, so whatever the which side it is illuminated, that is the not a matter. Okay, that the option is wrong. And so majority of the whole electron pairs swept are reversed across the junction. So this is also wrong. So yeah, option C is right answer. So reverse saturation current is small compared to the photo current. I already explained you. So that's why that was only the main reason. So we are connecting the photodiode in reverse bias. Okay. Yeah. So last one, the maximum wavelength of photons that can be detected by photodiode made by the semiconductor of band gap 2 electron volts. Yeah. So how you will find the maximum wavelength here?
Eg is equal to h by lambda.
Yeah.
H lambda.
Uh, Not H lambda. E is equal to
H
H
by
nu.
lambda.
E is equal to H nu. Okay. So H nu means C by lambda. So E is equal to HC by lambda. Understood? E is equal to
Yes,
HC
sir.
by HC by lambda. HC value is 12,400 nanometers. Okay, 12,400. So sorry, 12,400. Yeah, nanometer. So by 2 here. Okay, lambda value is so by 2. So if answer will be 620 nanometer. Okay,
Yes, sir.
so option A is the right answer. Okay, this is about the So answers of the, yeah. Now we
Sir,
are going to the, yes.
sir, according to the key, uh,
Mm,
I got 3 wrong, sir. Means I have answered 3 wrongly, sir, after your
okay.
explanation. But I
Mm.
got 25 marks, sir.
So what is your rule number?
5J not, sir.
5J naught. Okay. So whatever the marks they given, that means automatically it will be generated for right answers. That key only we are uploaded. Okay. So you got 20 marks and 5 marks will be,
20.
so 20 marks on that. I think 5 wrong for you. Okay. So you
Just
got
now
20
we
marks.
checked the key, no, sir. I
Uh,
I got
so
25
I
marks,
think,
sir,
yeah.
totally.
So I think you forget some two wrongs. I think. Okay.
No,
So
sir, because just now we have discussed that uh, 1.26 Armstrong is there, no, sir.
yes, yes. So yeah, that
That's
only
only.
I will check the key on that. So that key will be correct only. So while discussing,
Yes, sir.
I discussed wrong. So I will explain you that also. Yeah.
So according to the key, I should get 27, sir, but I'm getting 25 itself.
So you got 20 marks only in that. So 5 marks will be assignment marks. Okay.
Yes, sir,
Yeah.
for 30 I'm saying, sir. For 30
Uh,
I need to get
yeah,
27.
yeah. So what is that question number?
Sir, even I am getting 28 after discussing the key, but originally I got 25.
Yeah. So answers sixth one. Sixth one answer is B. You have check once. This is in nanometers only, I think. Okay. So option B is correct here. So check the
So
formula
just now
once.
I checked the textbook, sir. It gave
Uh,
12.26 by under root of V Armstrong itself, sir.
angstroms. Okay, I will discuss with the other faculty, and so I will try to make the correction on that key. Okay. Yeah.
Yes, sir. But sir, we are according to you all. I need to get 27, sir, but I got 25
So
because I
so
remember
take
the
the
questions, sir.
uh, okay, whatever it will be there, that is the right only auto generated marks, those all. Okay. So if any key will be wrong, that is the problem. Otherwise, so that is the auto generated. We not reduced for anyone. Okay. Yeah. So if any chance will be there, we will try to add. Otherwise, so we can't. Okay. Yeah. So now we are going to the solar cell. I will give the just introduction about the solar cell here. Okay. In last class, we discussed about the and discussed about the what is that photodiodes. So PN junction photodiode, PIN photodiode, APD photodiode. Okay. So what is the working principle of these photodiodes? So whenever light absorbed, so whenever light is instant on that these photodiodes, what happened? So those light is captured by the photodiode. That light energy is converted into here electrical energy. Electrical energy. So that is the application. That means that is the principle here, working principle of these photodiodes. Now coming to the solar cell here. Okay. Yeah, solar cell. So this is the solar cell is photovoltaic device that converts same light energy into electrical energy. So same principle. So here also applicable. Okay, what is the difference also I will explain you. Okay, solar cell is the photovoltaic device that converts light energy into electrical energy. Okay, starting we discussed so photovoltaic device and so normal connection. So while before going to the these diodes, I will explain you so different constructions. Yeah. So this is the photovoltaic mode and this is the photoconductive mode. Photoconductive mode. In case of all diodes, we are using this mode, photoconductive mode. Okay. So that means we will supply the external voltage. So we will supply the external voltage, and so that means we are connected in reverse bias. we are connected in reverse bias. So here diode is connected in reverse bias. Okay, and ammeter we are placing to measure the current passing through that. Okay, and here, so in this case we are not connecting any external voltages, that is the difference between the photodiode and photovoltaic diode, and photovoltaic diode. Okay, so photovoltaic diode, where it can be used, in a solar cells, solar this construction same here. Also we are using diode, here also we are using diode, same, both cases we are using diode only, but here we are connecting in reverse bias, here we are not connecting in any bias, we are not supplying any external voltage. That is the difference between the photodiodes and photovoltaic diode. Okay. Now, so this is the solar cell is photovoltaic device that convert light energy into electrical energy. Okay, this device work on the principle of photovoltaic effect. Okay, what is the photovoltaic effect? So first of all, what is the photovoltaic effect? We will discuss the generation of voltage across the PN junction in a semiconductor due to absorption of light radiation is called as photovoltaic effect. Okay, so here what is the photovoltaic effect means, whenever light is instant on the junction diode, PN junction diode, what happen, it absorbs the light energy, and that light energy is converted into voltage, okay, so that is the photovoltaic effect, definition. Okay, the device is based on this effect is called as photovoltaic devices. Okay, so these devices, so which devices work based on the photovoltaic effect? Okay, those devices we will call it as photovoltaic devices, So once again I will repeat the what is the definition of photoelectric effect. The generation of voltage across the PN junction in a semiconductor due to the absorption of light radiation is called as photovoltaic effect. This definition is very important one. Okay, and so those type of devices we will call it as photovoltaic devices. Now next point, the solar cell is basically a PN junction that can generate electrical power when light is illuminated. Okay, so here solar cell is a basically PN junction diode only that generates the electrical power, so while light is illuminated on it. Okay, next point, cells are usually large area devices typically illuminated with sunlight and are intended to convert the solar energy into electrical energy. Okay, see here, solar cells are usually large area devices. So in case of photodiodes, only what we said that only intrinsic region absorbs the light energy. But here, not only intrinsic region, total entire semiconducting material absorbs the light. Okay, so here generally, so which light it is converted into electrical energy? Sunlight. Okay, so that's why, so generally we will call it as solar cells. Sunlight is so illuminated on those material, so those sunlight is converted into electrical energy. Okay, that means that solar energy is converted into electrical energy here. Okay, and construction and working. Okay, now how to construct the solar cell material means, initially we are taking p-type material. It consists of p-type chip. So basically previous cases we are taking n-type material or n-type chip, and we will dope on that n-type material. So we will dope the p region, but here we are consist of p-type chip. Okay, we are taking the p-type chip, which a thin layer of n-type material is grown. Okay, So that means we are taking here p-type chip, thin layer of n-type layer is grown on that p-type layer. Okay, when solar radiation is incident on the cell, electron hole pairs are generated in the p and n region. In case of photodiode, only intrinsic region, what happened? So that electron hole pairs will be generated. But here, so both regions, so both p region and n region, here electron hole pairs are generated. Electron hole pairs are generated. We are not connecting in any reverse bias or forward bias. Okay, just so that is the p-n junction diode. So we are keeping that p-n junction diode in the presence of solar energy, in the presence of solar energy. So whenever solar light is incident on that p-n junction material, p-n junction diode material, what happen? That total light is absorbed by the, so both regions, p region and n regions, and so electron hole pairs will be generated. Okay, next point, the majority of them cannot recombine in the regions. Majority of them cannot recombine in the regions. They reach the depulsion region at the junction where the electric field due to the space charge separators them. Okay, so already while preparing the p-n junction diode, already I said that, so while preparing the p-n junction diode, if you dope the one side p region, if you dope the another side n region, what happen? So those so in between the p region and n region, depulsion region will be formed. What is the reason? Means space charge carriers will be separated at a particular distance. Space charge carriers separated at a particular distance. Okay, because of those space charge carriers, so what happened here? uh, so that the depulsion layer will be formed. Depulsion layer will be formed here also. So here also what happened means, so whenever light is incident on the either p or n regions, so electron holes pair will be generated. Electron hole pair will be generated. Some are recombined within the those region only. Some are recombined, so either itself p region or itself n region only. So some charge carriers reaches to the junction. Some charge carriers reaches to the junction, and what happened means, so charge carriers are accumulated on the junctions. Charge carriers are accumulated on the junction means, what happened means, potential difference will be increases. Potential difference between the, so p region and n region will be increases because of the accumulation of the charge carriers. P region and N region. So potential difference between the P region and N region will be increases. Okay, so that means the potential difference is increasing means automatically electric field will be produced. Okay, so we'll discuss remaining tomorrow. So this is the just introduction about the solar cell. Okay, yeah. So if possible, so some, that is the only one answer you said that. So I will check that answer on that sixth question. Okay. So whether it will be okay means, we'll try to add the marks. So we'll try to add the marks. So I am not sure. Okay, for that. So first of all, I will take the download the attendance. If you have any doubts means you can ask. Otherwise, you can leave from the session.